This is Math 140, day 12, with our second group of topics that cover the big chunk of Module 5, and that's distance and midpoint and circles. This concept from geometry, but of course we're linking them with algebra. To begin with, we're looking at the distance of 2 points in the plane. Give them names. Let's call them x, y, and a, b. In the plane. If we sketch this, x, y, a, b. What can we do with algebra to calculate that distance? Of course, it's the length of this line segment. But how can we calculate that length? And here's where Pythagoras comes in. That was one tiny topic in Module 4. And this comes in handy because if we have a coordinate system, okay, with coordinates x, y, a, b, then we can make lines straight down or vertical, parallel to the y-axis and parallel to the x-axis, so that we get a right triangle. And with the coordinates that we have for these two endpoints of the line segment, we can calculate the length of the legs of the right triangle. And the length of the horizontal leg is the absolute value of x minus a. With that absolute value, I can cover all possible cases, whether a is to the left or to the right of x. Just take the absolute value of the difference, and you got that length. Now for the vertical leg, it's the absolute value of y minus b. And then Pythagoras says the length of the hypotenuse squared so let's write for that the distance between those 2 points. If you square it, then that is equal to x minus a squared plus y minus b squared. I did write absolute values here, but of course when you square them, we don't really need that absolute value anymore. We can just write parentheses. And if you take square roots on both sides, which we can, because none of these things can be negative, then we get this distance. The hypotenuse is just a crutch. The distance that we're after is the square root of x minus a squared plus y minus b squared. Fine. That's one topic. Distance between 2 points in the plane. And now let's take this for a spin and calculate the midpoint of a line segment. again, between x comma y and a comma b. And here, I'm going to just tell you the formula for it because it's beautiful and simple. And the definition of midpoint would be more complicated because midpoint is going to be that point on the line segment, which is exactly halfway. So the distance of it to the endpoints is the same. I had this sketch, so I can't resist the temptation to sketch a midpoint of that hypotenuse. That would be about here, right? So we want a formula for this midpoint. And that formula is just simple and beautiful. You take the average of the 2 points x values, x plus a divided by 2, and the average of the y values, y plus b divided by 2. Take 2 coordinates, and you've got a point, and that's the midpoint. Why is that working? I would say, imagine for a second that x, y is actually 0, 0. And then a comma b is somewhere out there in the plane. So it means stepping a steps, a units to the right and b units up, or if b is negative, its absolute value of b units down. And if you just do half of that, then you land at the midpoint. Half of the units to the right, half of the units down, you get the midpoint. So in that case, when x and y are 0, it's plausible. And then you've got to argue, why does it still work if x and y are not 0? And it's quite lengthy to check that this is true. We're not going to do it. This is the formula for the midpoint of a line segment. And now I can finally get to the most interesting topic, which is circles. That's connected to the previous video because it's equations that describe relations between x and y. But geometrically, of course, let's start with the geometry. A circle, the circle, about point a comma b, that is all points with distance, fixed distance r from that point. I suppose everybody knows that. And because we've got an equation, a formula for the distance, we can write down such an equation for the circle. X minus a quantity squared plus y minus b quantity squared. So that's the square of this distance that we are talking about. And therefore, it's going to be r squared. If you take square roots on both sides, and you would just have the r. And I would call that the standard equation for the circle about a comma b with radius r. R is called radius of the circle. Whenever you got center and radius, you describe that, you have nailed that circle down. You've completely described it, and we can transition from the equation back to the circle, to the geometry, by finding center and radius. If your equation is not in standard form, then we've actually got to do some work for it. So here's the equation: x squared minus 6x plus y squared plus 8y equal to 0. And I'm just telling you, yes, that does describe a circle, but find me the center and the radius. And what to do? This is a wonderful segue from the last module, because we've just learned about completing the square. It's like brainwave. Complete the square 2 times. You got the x squared minus 6x. And we would love that there was a plus 9 here, and you know why after the last module. And with the y squared plus 8y, we would love that there was a plus 16, right? Right? But that changed the value here. We just can't add willy-nilly a 9 and a 16. So we add the 9 and the 16 to the right-hand side as well. And then we've got an equivalent relation. It describes the same points in the plane. And now we've got it in manageable form. The first thing is x minus 3 quantities squared. And the second one is y plus 4 quantities squared. And on the right, we have a 25. Now it's in standard form. And you can just read off the center. Number A is, pause the video if you're unsure, think about it, because I'm going to give it away. It is 3. Comes from this number 3 here. And the B, which comes from that 4, but we want to see y minus b. So minus b has to be 4, and therefore b is negative 4. And the last thing, r squared is 25. So r is the square root of 25, which is, of course, 5. Radius 5, the center is 3, negative 4, and the radius is 5. Squeeze that in. And to just spell this out, I mean, A is 3, B is -4, really told me what the center is, but to write it as a point, you want to put it in parentheses. Well, that's how to get from an equation, which is a beautiful example for a relation that's not a function, to the geometry and center and radius, and to sketch such a circle. I can just emphasize that that's going to be this. Definitely does not pass the vertical line test. Okay, there's plenty of vertical lines where the line hits the circle 2 times, so it's not a function, but it's a relation, a beautiful one, and in particular it is a circle. Now we can also go the other way. That's the last thing I should do, and that is, given various things about the circle, find me an equation in standard form. Given center, which could be 3 and -2, and 1 point, which should be 1,7, because I say so. Find the equation for circle determined by these 2 data, these 2 clues. And we want it in standard form. Right, so we need 3 ingredients, 3 numbers. It's the A and the B for the center, and that's just given the 3, -2. And the radius, what's the radius? Radius squared is the distance between any point on a circle, like 1,7, and the center. So let's take that 1 and 7. Difference between x coordinates, it's 1 minus 3, quantity squared. Difference between y coordinates, 7 minus -2, quantity squared. So that is 4 plus 9 squared, which is 81. And the radius is square root of 85. And we can just write down our equation in standard form without any further computations. X minus 1, quantity squared. Sorry, minus 3. Center was 3, -2. So x minus 3, quantity squared, plus y minus -2. That's y plus 2. Quantity squared is 85. Radius squared. Here's your beautiful equation for that circle. And there's a couple more ways when they just give you 2 points on a circle that are a diameter. So the line segment between them goes through the center. And that's when you need to calculate the midpoint of that diameter, because it gives you the center. So that's how those topics all are linked together, and you really have to do midpoint and distance, and then you can really understand circles and do algebra with them. Thank you. That's enough for today.